Hey friends, welcome back to Math Defined. Today we're learning how random samples help us make conclusions about a population and why different samples can give us different answers. Let's jump right into our first example. Take a look at this survey given to 900 students in your school about their favorite Winter Olympic sport. Instead of surveying everyone, you and 4 friends each surveyed 20 students. Let's take a look at the results of those random samples. Out of the 4 choices, we're most interested in finding an estimate for how many students in your school chose downhill skiing as their favorite Winter Olympic sport. 13 students told you that downhill skiing was their favorite. We'll write that number as a fraction out of 20, representing the 13 out of 20 students you surveyed. Then we'll convert the fraction into a decimal using division. 13 divided by 20 is 0.65 or 65%. So from your sample, we can estimate that 65% of the 900 students in your school chose downhill skiing. But how many actual students is that? We'll find that out by multiplying the decimal number by the total number of students, 900, to get 585 students. Pretty easy. Let's finish filling in the table using the samples your other 4 friends collected. Friend A had 8 out of 20 students. Multiplying that by 900 gives us 360 students. Friend B had 10 out of 20, giving us 450 students. Friend C had the same number of students as friend B, so that's easy, 450 students. And friend D had 9 out of 20, giving us 405 students. Do you notice that except for friends B and C, the rest of the estimates are different? These differences happen naturally because we would expect that students' choices will vary from person to person, which is why it's never a good idea to rely on just one sample. Finding estimates is only the first step in understanding your student population who chose downhill skiing. We need to find the center and the variation of these estimates to get a better picture of the student population as a whole. First, we'll find the center, which is the median, or the middle value of the estimates. We'll need to list them in order from least to greatest: 360, 405, 450, 450, and 585. Now, the easiest way to do this is to cross out a low value and then a high value until we find the middle estimate. The median estimate of 450 students could be a reasonable estimate, but we need to look at the variation, or how spread out the estimates are, to be sure. To find the variation, we'll need to find the range of the estimates. It shows us how the estimates change depending on the sample. We'll take the highest estimate, 585, and subtract the lowest estimate, 360, to get a range of 225. So the range for choosing downhill skiing is 225 students, which is a fairly large range. Remember, we're estimating out of 900 students. A difference of 225 students means the estimates change by about 1/4 of the school, depending on the sample. These estimates are not very close together, so there is a lot of variability in these samples. This doesn't mean the samples are bad, it just means we should be careful and look at all the samples together instead of trusting just one estimate. Now let's take a look at another situation where we use multiple samples, but this time our focus is on the mean, or the average of the estimates, and how they can vary from sample to sample. Let's say that you want to know the mean number of hours high school students in your district study each week. The population for your survey is all high school students in your school district. Instead of surveying everyone, you randomly survey 10 students at each of the 6 schools. Each school gives you a separate random sample. Let's find the mean number of hours studied for each school. Each number in the table represents the total number of hours studied by 10 students at that school. For School A, 10 students studied 70 hours. To find the mean, we'll divide 70 by 10 to get a mean of 7 hours. For school B, we'll divide 73 by 10. School C is 77 divided by 10. School D will be 50 divided by 10. School E will be 80 divided by 10. And school F is 90 divided by 10. So our sample means are 7, 7.3, 7.7, 5, 8, and 9. Just like the estimates in the previous survey, our means representing our samples here are not all the same. That's variability at work again, and totally expected. Now let's combine all the data. Altogether, the students studied 440 hours, with 60 students surveyed in total. So to find the overall mean number of hours that high school students studied in your school district, we divide 440 by 60 to get about 7.3 hours. So we can estimate that high school students across your school district study about 7.3 hours per week. But was this a good sample? Can we trust the results? Let's see if the center and the variation of the means support our conclusions, or conclusion, that students studied about 7.3 hours per week. Let's find the median for our means first. Remember, when you have an even number of values, you have to find the mean of the two left in the middle. So the median is 7.5 hours, which is close to the overall mean of 7.3 hours. So the estimate of 7.3 hours spent studying appears typical and reasonable. Now let's find the range of the means. 9 minus 5 is 4 hours. 4 hours shows us that there is some variation between schools, but the values are not extremely spread out. The mean estimates were centered around 5 to 9 hours. A variation of 4 hours is reasonable, so the conclusion that high school students in your school district study about 7.3 hours per week is supported. So while the result isn't exact, it's still a reliable estimate. Now it's your turn to try one on your own. Take a look at this situation. A restaurant owner wants to know which appetizer is preferred among 600 people who visit the restaurant. Instead of surveying everyone, 3 servers each randomly surveyed 20 people. The table shows how many people in each sample chose salad or bread. Here's what I want you to do. Focus only on the number of people who chose salad in each sample. Use each sample to make an estimate for how many people out of 600 might prefer salad. Go ahead and pause the video, work it out on your own, and then come back when you're ready. All right, let's check your work. We're estimating how many people out of 600 might prefer salad using each random sample. Let's go sample by sample. Sample A, 11 out of 20 chose salad. 11 divided by 20 is 0.55, and multiplying that to 600 is 330 people. Sample B, 14 out of 20 chose salad, giving us 420 people. And sample C, 12 out of 20 chose salad, giving us 360 people. So the 3 estimates are 330, 420, and 360. Now that you have your estimates, let's describe the center and the variation of the estimates. Go ahead and pause the video, find both the center or the median and the range. Come back when you're ready to check your work. All right, let's find the median of the 3 estimates. To find the median, you first list the estimates in order from least to greatest. Now find the middle value. The median is 360 people. Now let's find the range. We'll subtract the highest estimate and the lowest estimate. 420 minus 330 is 90. So out of 600 people surveyed, the estimates only differ by 90 people, making the results fairly close together. So what conclusion could we make about this restaurant population? Pause the video for a moment to think about it. We could make the conclusion that out of 600 people eating at the restaurant, about 360 would prefer a salad for their appetizer. Which appetizer would you have chosen? Which one would you have predicted to be the preferred choice? Sometimes surveys like this surprise us with the results. But we have one last consideration. Would you consider the estimates from this survey valid? Well, the samples were random. Each sample was the same size. Multiple samples were used, not just one. And the estimates are different, but not widely spread out. So, yes, you can consider the estimates from this survey to be valid. Thanks for watching, and please take a moment to help support Math Defined. Smash the like, hit subscribe, it's free, and helps you keep up with new lessons. I'll see you soon, and as always, keep math awesome.